In this video, we are going to discuss about design and simulation of dynamic and pseudo NMOS logic. So this is a basic structure of the dynamic logic. So in dynamic logic, we will be having NMOS section, that is pull down section will be implemented. Then there will be a one PMOS, one NMOS. It will be there. Here we will be connecting your clock signal. It consists of, when clock equal to 0 means it will be pre-charge mode. When clock is equal to 1 means it will be act as the evaluation mode. We will be tapping output from this place. So this is our design we are going to draw in this experiment, that is NAND gate, dynamic logic representation of NAND gate. So in NAND gate, in NMOS represented as series combination. So two NMOS are in series. Here we will be applying the clock for this PMOS and NMOS. The advantage of dynamic logic means we can reduce the number of transistors. Then we will be tapping out from this position. This is a clock signal we are applying. This is the input A as well as B for NAND gate. So this is our expected output for the NAND gate using dynamic logic. This is A input, this is a B input. Here we are applying clock signal. When clock equal to 0 means it is pre-charge mode. When clock equal to 1 means high means evaluation mode. So in pre-charge mode, our input, last case the inputs are 1 1. So NAND gate output will be 0 for this evaluation phase. So next in pre-charge phase, so in this position the input is 1 1. Again the output will be 0. So this is the output of the NAND gate for the dynamic logic. Next we can see how to draw this dynamic logic NAND gate in SEdit. Double click SEdit. Now it is open. Go to File, New Library. Go to Browse. Open a folder. My dynamic. Click OK and click OK. Again right click. Add library. Browse. Go to the folder. Generic underscore 250 nm. Select the generic underscore 250 nm underscore devices. Then click OK. Again right click. Add library. Browse. Go to the folder standard libraries. Select MISC. Click OK. Again right click. Add library. Browse. Select the folder spice underscore plot. Then right click. Add library. Browse. Select spice underscore sources. Click OK. Then click OK. So the basic library components, everything added. Then go to cell, new view. Click OK. Go to generic underscore 250 nm devices. First select the PMOS instance. Pick it and place it here. Then we need NMOS. For representing logic, we need 2 NMOS. And finally, for giving clock signal, we need one more NMOS logic. Then take the wire. To fit the screen, press home button. Here we are taking output. See, take the input port, place it here. Here we are giving the clock. Then go to spice source, select vpulse instance, place it here. For input we need another one vpulse. For this input we need one more vpulse. Take the input port, name it as A. Take another input B. Take a wire, join this A input with this transistor, similarly B with this transistor. Next take VDC instance, place it here. Then we have to take the VDD, the connection as ground. For printing the output, displaying output, place the voltage print. Next, for this all the combination of input, you can change the period of the pulses 100. Next, go to setup simulation. For transient analysis, 400N, here 4N, general, add the library file, browse, select this library, open, go to the end of the file, type TT, then click OK, then click start simulation. Expand this. So this is a clock signal. So in clock initially we have to give it as 0. So go to the design, set it, change the clock. Here I'm giving clock pulse 100 and the delay time is 45. Here we can see for this NAND gate, this pre-charge mode, here input is 1, so this is our output. At this time pre-charge mode, clock equal to 0. In evaluation mode, output will be 0 for NAND gate. Then for this time period, when input is 0, 1, this is in pre-charge mode. In evaluation mode, output will be changed to 1. So this is output of the NAND gate using dynamic logic. Dynamic logic output for the NAND gate. In evaluation mode, we have to see the response. This is evaluation mode. When clock is high means it is in the evaluation mode. Next we can see pseudo NMOS logic structure. So this is a basic structure of pseudo NMOS. So there will be a single PMOS will be there. It is connected to ground. Gate is connected to ground. Then there will be a pull down section there. So this is a structure of NAND gate for the pseudo NMOS. Here the PMOS section is gate is connected to ground. The NMOS logic representation of NAND gate. It is two NMOS transistors are in series. Here we are tapping our output. So this is output of pseudo NMOS. We are giving 1 1, output will be 0. Then 1 0, output will be 1. So 0 1, output will be 1. 0 0, output will be 1. 1 1, output will be 0. This is a output of the NAND gate for pseudo NMOS logic. Next we can see how to draw the pseudo NMOS structure in Tanner EDA version 2019.2. Open SEdit. Go to File, New Library. Open a folder. Pseudo NMOS 1. Click OK. Right click. Add library. Browse. Go to full generic connectivity num_ devices. Click OK. Click OK. Right click. Add library. Browse. Go to standard libraries. Click MISC. OK. Then add library. Browse. Spice_plot. Click OK. Add library. Browse. Select the folder spice_plot. Spice source. Right click. Add library. Select spice source. Click OK. Next, go to cell, new view. Click OK. Go to generic connectivity num. Select PMOS. PMOS. Then take NMOS. two NMOS are in series. Go to the screen. Then take wire. Use wiring connection. Connect the wire. Next, go to MASC. Select ground. Here connect. We can PMOS connected to ground. Here we need one more ground. Here we will be applying the input. So go to spice underscore sources. Select the V pulse. Here another V pulse, you have to place it here. Then take the port, press A, B, take the wire, here we will be taking output, port is out, you can say C, then take spice underscores VDC, take MASC, VDD, for printing voltage, plot the display, we have to connect print voltage, click instance, so we will be getting 3 plots. For giving different combination, I am changing the pulse to 100. We will be getting all the combinations. Then set up simulation, add the library, browse, generic underscore 210nm.lib, type TT and the end of the file, select the transient analysis, 400 EM, 4 EM. Then run the simulation. So this is output of NAND gate using pseudo NMOS. So here 1 1 output will be 0, 1 0 output will be 1, 0 1 output will be 1, 0 0 output will be 1. Again it is repeating up to 400 nanosecond for the transient analysis. Thank you for watching.